Solving systems of equations with matrices. This is your tutorial. The directions say write the augmented matrix for each system and solve. Show the RF output from the calculator, and then write your solution as an ordered pair or as ordered triple. Now, before we can use matrices, the equations have to always be written in standard form. And make sure when you write it in standard form, they go in alphabetical order when you're dealing with X and Y for sure. And if it's not X and Y, make sure you remember the order so that it's consistent when you get your output. But we'll demonstrate that more in just a moment. So on number 1, I noticed that the second equation is not written in standard form. The first equation is fine, so let's just rewrite it. X minus 2y equals 0. Let me curl my y. There we go, so it doesn't look like a 24. Now, the second equation is written in slope-intercept form. So that means I have to take away 2x and bring it back to the same side that y is on. So when I do that, then the equation would say negative 2x plus y equals negative 3. Now both equations are in standard form. My x's are first, both of the time, and my y's are second, keeping them in alphabetical order. Now I can write my matrix, my augmented matrix. Augmented matrix is nothing but all the numbers from your equations, but no variables. So for equation 1, that would be 1, negative 2, and then 0. For equation 2, that would be negative 2, 1, and negative 3. Now we grab our calculator. To get the RF to appear on our screen, we would hit second, matrix, go to math, and then alpha apps. And then RF is now on our calculator. To type in our matrix, we need to set up our matrix. So we would hit alpha, zoom. Currently, it's on OK, so we have to use the up arrow to tell it how many rows and how many columns. So this matrix has 2 rows. Remember, rows go across, like the rows of the auditorium. So 2 rows. Hit enter to change it to 2. And then we have 3 columns. Columns hold things up, so columns go up and down. Make sure you remember that. Rows go across, rows of a theater, rows of an auditorium. Columns go up and down because columns hold things up. Columns hold buildings up and things like that. So keep that in mind. And then once you've selected the number of rows, the number of columns, come down to OK, select it. Now we enter all of our elements, hitting the right arrow. So you can only do one row at a time. So 1, right, 2, sorry, negative 2. Make sure you hit negative 2, not minus 2. Then 0 is fine. Then we need negative 2 here for the first element, positive 1, and negative 3 for the third element. Double check to make sure that your calculator screen matches the same matrix you wrote down on paper. And then we can hit enter. Now let's write the computer output per instructions, or calculator output. So the calculator says it's a 1, 0, 2 followed by a 0, 1, 1. So I told you before that what comes after that line is your outcome. This is X and this is Y. As long as X came first, X will come first in your output. So the solution to this system is 2, 1. All right, when I look at number 3, the first equation is 5x minus y equals 4. Second equation, negative 2x plus 6y equals 4. So both x and y are on the same side, and they're in the correct order. So I can start first with my augmented matrix. There's no moving around in this case. So my first row would be 5, negative 1, 4. My second row would be negative 2, 6, 4. And now we're ready to put this into the calculator. So again, second matrix, math, alpha, apps. Then we do alpha zoom. Again, we have 2 rows and 3 columns, so we simply hit OK, and there's our matrix. So the first row is 5, negative 1, 4. Second row, negative 2, 6, 4. And then our output matches, or our input, that is, matches what's on our paper. So now hit enter and write down our output. We got 1, 0, 1. We got 0, 1, 1. So that means the solution to our system is 1, 1. Number 5, we have 3x minus 4y equals 12. 1/3 x minus 4/9 y equals 4/3. So we're already in standard form. So our augmented matrix would look like 3, negative 4, 12 on the first row, 1/3, negative 4/9, and 4/3 on the second row. Yes, it has fractions, which is perfectly fine. You're using a calculator. I'm going to use a little cheat method since it has the same number of rows and columns as the previous problem. And let's say I don't want to go through all the keystrokes. Just highlight the previous one, hit enter, it brings it down. So now you just have to go and change all of the entries. Just be careful with that to make sure you don't forget an element. So 3, negative sign's already there. Just type my 4 now. And now I type 12. I don't need a negative sign here. So delete, delete. But I do need a fraction. So we go alpha y equals 1 for a fraction. 1/3. All right, now I'm on the 6. Let's delete that. Now it's empty. Now we need a negative alpha y equals 1, 4/9. You could choose to put the negative sign in front of the fraction or with the numerator. Either way, it's fine. As long as the negative only appears one time, it's fine. And then my last one would be alpha y equals 1 for my fraction, and then 4/3. Now everything looks right, like it should. Double check, yes, and yes. So we hit enter. Now let's write down our output. We have 1, negative 1.3, repeat, followed by 4. Then we have 0, 0, 0. Now, this output doesn't look like the previous outputs. Remember, we're supposed to have our identity matrix right here. But this is not an identity matrix. So the last statement says 0 equals 0, which is a true statement. So because 0 equals 0 is a true statement, this has infinitely many solutions. In other words, any point on this line, because it's only one line, is a solution. So what ended up happening in this scenario is that these two equations represent the same exact line. If you were to put it in y-intercept form, slope-intercept form, you would have noticed that. And so it's infinitely many solutions. So on the back side, we start getting into the triple variable systems. Even more so on this side, you really got to pay attention to the fact that everything's in alphabetical order if it's X, Y, and Z. And remember the order that you keep your variables in if it's not. Um, and also make sure, again, that they're all written in standard form. So when I look at number 7, I have 2x plus y plus 3z on the first equation. On the second equation, I have x minus y minus z. And then on the third, I have 3x minus 2y plus 3z. So all three variables are on the left-hand side in every equation. So we're in standard form. Now we can write our augmented matrix. So the first row would be 2, 1, 3, negative 2. The second one would be 1, negative 1, negative 1, negative 3. And the third would be 3, negative 2, 3, negative 12. Okay, so now we can grab our calculator. And since this matrix does not have the same amount of rows and columns as the previous one, I have to go through all the keystrokes again, which is totally okay. You can do it. So second matrix, math, alpha apps for RF. Now we go to alpha zoom for our matrix. This time we have 3 rows and 4 columns. And then select OK. In the first row, it's 2, 1, 3, negative 2. Then we have 1, negative 1, negative 1, negative 3. Lastly, we have 3, negative 2, 3, negative 12. Please make sure you probably need to read it aloud like I do and double check to make sure everything looks good before you hit enter. And now we can hit enter. So the output was 1, 0, 0, -1. We have 0, 1, 0, 3, 0, 0, 1, -1. So again, it's in alpha order, like it was when it was a 2 by 3. So this is x, this is y, this is z. We write it as an ordered triple. So the solution is -1, 3, -1. And again, you have to have that identity matrix on the left. When you don't, something's incorrect. So it's either no solution or many solutions. All right, when I look at number 9, the first equation is written in standard form, which is awesome. The second equation is also written in excuse me, is also written in standard form, but if you notice, y is missing. Same thing with the third equation, y is missing. So I don't have to add or subtract anything to each side, but I'm going to have to remember that y is missing when I'm writing my augmented matrix. So this matrix, the first row would be 1, 1, 1, 3. The second row leads with 13 because that's where x is. Since I don't have a y, I have to put a 0 in its place. And then 2 for z, and then 2. On the last row, I would have -1, again 0 for y, -5 for z, and -5. And now we grab our calculator. Again, we have the same rows and columns as before, so we can highlight it and bring it down. Save us some time. And then just type over the previous information. Ooh. All right, so 1, 1 is fine there. And 1, delete the negative, and type 3. We need a 13 here. We need to delete the negative and put 0. Delete the negative and put 2. Delete the negative. We need another 2. We need a -1 on the first element. Delete the negative. We will need a 0. We need to add a negative and put a 5. We can keep the negative, but delete the 1 and put a 5 for the last row. Double make sure everything looks good. Now we can hit enter. So our output was 1, 0, 0, 0, 0, 1, 0, 2, 0, 0, 1, 1. We got the identity matrix on the left. Yes, we do. So the solution to this system is 0, 2, 1. Now on number 11, automatically the second equation looks shorter. So that should be a red flag. Not only is it shorter, but x and y are not on the same side. So you would have to add y or add 2y to both sides to cancel it out. So the new equation 2 would say 3x plus 2y equals 0 because you canceled it out on the right, which made nothing left there. And now you can write your augmented matrix. So on the second equation, we're lacking z. So when we write our augmented matrix, don't forget to put a 0 in its place. So row 1 is 5, 3, 1, 4. Row 2 is 3, 2, 0. Again, there's no z. And then another 0 to represent what comes after the equal sign. And then the third row is 2, -1, 3, 8. Okay, we can copy and paste. And now I need 5 first, then 3, the 1 can stay, and 4. Delete the 1, the 3 can stay. I need a 2 and a 0 and a 0. Delete the 0, or I'm sorry, delete the negative 2. I need to add a negative 1. Delete the negative 3. Delete the negative and an 8. So my output is 1, 0, 0, -2, 0, 1, 0, 3, 0, 0, 1, 5. So I have my identity matrix on the left. Great. The solution is -2, 3, 5. So for 13 and 14, you're going to take the description and write your system and solve your system. You can solve your system using matrices, substitution, elimination, graphing, whatever your heart desires. You've learned 4 methods so far. Nimitz is selling tickets for the spring dance performance. On the first day of ticket sales, Nimitz sold 3 adult tickets and 1 student ticket for a total of $38. Nimitz took in $52 on the second day by selling 3 adult tickets and 2 student tickets. So our unknowns in this scenario are adult tickets, so I'm going to use A, and student tickets, so I'm going to use S. On day 1, there was 3 adults sold, so 3A, plus 1 student for a total cost of $38. On day 2, it was 3 adults, 2 students for $52. So this is how our system would look. I'm going to practice using matrices. Both of my equations are in standard form. Great. So the augmented matrix would be 3, 1, 38. On the second row, 3, 2, 52. Now we grab our calculator. We need to hit second matrix, math, alpha, apps, alpha zoom. Oops. We have 2 rows. We have 3 columns. Again, you can use any one of the methods we've talked about so far to solve this. So not having a graphing calculator for problem 13 or 14 is not an excuse. All right, so 3, then 1, then 38. 3.252. Got it entered properly. Hit enter. So my outcome is 108.0114. So again, if A comes first, A comes first in your equations, it comes first in your output, and S comes second, which is a little interesting because it's saying that student tickets are more expensive than adult tickets. Adult tickets cost $8, whereas the student tickets cost $14. Whoa, that's expensive. But that's the reality. That is the reality that this problem is living in. It's not realistic. It's usually the other way around, but that's just what happened. This concludes your tutorial for this lesson. Good luck on finishing the rest.